G'day and welcome to another edition of Scripting Adventure. We're continuing the series on creating a fully custom parametric door in GDL. In the last episode, we scripted our glazing bars, we scripted a circular prism with a circular hole, and also cut our geometry using the cut poly A command to achieve a circular cutting body. In this episode, I'll cover the complexities of removing unwanted lines between adjacent geometry, but also how to keep wanted lines between adjacent geometry using the body -1 command and the model wire command combined with the right status codes. I'll also show you how to add conditional limitations to various parameters using the values command to prevent the user from inadvertently breaking the object. This is good stuff. Now to get rid of these lines separating our different geometry declarations. Now there's various ways you can deal with that. One way is to just change the order in which you declare these commands. For example, if I move this declaration of my horizontal glazing bar, this one, above the declaration for the circle, for example, I get rid of those lines there. But that will only take me so far. I won't actually get rid of these lines here. So just undo that. And so what I'll do to get rid of those is use the body command. Now, the body command is a little bit, it's pretty hard to figure out. I haven't got all the logic figured out. What I'll do is I'll add a body -1 command up here. That treats previous geometry commands as a single body. So I'll put it up here, no change. And I'll put one down here as well after the leaf frame. So after this declaration here, I'll put in another one, body -1. And you can see that that has got rid of all of those lines. But it's got rid of all of those lines as well. So this is where it's a bit hard to figure out exactly how this command works. If I comment out the one for the frame, those lines have disappeared, but these lines have come back, as well as these lines here. I want to get rid of these ones and these ones. So if I get rid of that one and turn this one back on, they've all come back. But if I turn both of them on, they've all disappeared. So what's the answer there? Well, the answer, the way that Graphisoft do their doors, is what they do is they declare a wireframe version first and then a solid version afterwards. So what does that look like? So I'll just repeat this command up here, and instead of getting all of my buffer coordinates, I will use the coordinates in my buffer. So that way it uses them but leaves them in memory, and then I'll get them down here, which uses them and clears them from memory. And then before this statement, I will go model wire, which turns my model into a wireframe, and then model solid, which turns my model back into a solid. So let's see what that does. Okay. These lines have remained merged or cleaned up with the single body command. These lines have come back because what's happening is I've got a solid body declared after a wireframe body in the same place. And so what you're seeing here is not the lines of my solid body, but the lines of my wireframe body. Now, the downside is that all of these segments are now showing again. There, and there, and there. So the way I deal with that, under my status codes, so I've been using a status code of 15, which will draw a vertical line for each face that it draws. I want to eliminate that line in my wireframe. So it'll be 13, status code of 13, which will only draw the top and bottom lines of the surface. So let's have a look at that. Start putting in some of these at the curve. So if I change that from 15 to 13, this is the outside one. Oh, no, that's the whole coordinates. Let's start at the top. The outside coordinates, 15, 15, 15. This is my first curve here. So when I change that to 13, what happens? That line there disappeared. So then I'll change this to 13 as well. There we go, all of those lines disappeared. So now I need to change it for that. There's those lines, still got those because I want them as a sharp edge. And now for the inside ones. It's that corner there, that corner there, that corner there, here as well. Missing one. Is it that one? That one there. There we go. All neat and tidy. Save that. Have a look at my Archicad model. Excellent. Looking good. Let's just do a bit of testing. If I shrink this down to a smaller size, what happens? See how it breaks if I get below a certain size? And this circle's too big. I need to put in some limitations on my parameters to make sure that this can't be broken. That's in your parameter script. That'll be in the values section. These are just sections that I've divided my script up into. You can do it in any order you like, but this helps me organize my script in a easy to understand manner. So the first limitation would be A. So we'll go values, parameter A. We want that to be a range, and we want the smaller value to be greater than. What do we want it to be greater than? We don't want A to be any smaller than this curve plus this indicator width plus that curve. We don't want it to be able to get any smaller than that. What's the curve? Jam radius by 2 plus indicator width. But we only want that to be part of the limitation if the indicator's turned on. So then we say indicator width times indicator on, remembering that this is a 1 or a 0 value. So if it's turned on, this will be indicator width times 1. And if it's off, it'll be indicator width times 0. Let's check our script. Missing comma. Oops, missing my maximum value. My maximum value will be nothing. So a curved bracket is greater than, and at the end it's smaller than. And if it was a square bracket, it would be smaller than or equals to. So there we go. I can't go any smaller than 800. And if this is turned off, smaller than 500. Good. My width now has that limitation built in. So I can't go small enough to break my object. So I can add those into other values as well. For example, this circle, I can't break the width, but that circle's now too big. So what we do is under our parameter script, we say values of our glazing bar diameter, the range, we want it to be bigger than, so open curly brackets, we want it to be bigger than the width of that glazing bar times 2. So I can't get small enough to overlap itself. So that's leaf frame width. It needs to be bigger than that. And it needs to be smaller than, let's have a look at our plan. It needs to be smaller than A minus our frame width minus our leaf width times 2. Needs to be smaller than A minus times 2. So let's have a look at that. It's bigger than 100, which is bigger than 2 of them, smaller than 800. So if my width was 1,000, it's 1,200. Let's make this 1,200 so I can check measure against my diagram. Smaller than 1,000. Smaller than 1,000. Excellent. So let's save that. Have a look at my 3D. I need to run my parameter script in order for that to take effect, which is just opening the parameters dialog. There we go. That's updated to suit. So if I change this to 1,200, change my center circle to be 800, and now reduce this down, you see that circle's getting smaller. So it's responding to the limitations I've put in there. Now I could put in other values as well to make sure that it doesn't get too big. I change the height. For example, you can see this is messing up here and so on. So you need to put in values to deal with all of these limitations to make sure that the user can't inadvertently break the object. We'll wrap this one up there. Now you know how to get rid of unwanted lines between adjacent geometry and how to keep wanted lines between adjacent geometry using the body -1 command and the model wire command combined with the right status codes. You also know how to introduce conditional limitations to parameters using the values command so that the user can't break the object. In the next episode, we will go over the Graphisoft Doors macro map, and I'll show you which macro to use for your door opening lines and how to get the basics of this into your object. I'll see you there.